Good morning to our host, fellow speakers and valued listeners. My name is Shaun Pillay. I'm the General Manager of Packlink Projects and Exports Africa, specializing in smart factory solutions and encompassing track and trace initiatives. Thank you to our host for the opportunity to share some insights into our projects and more specifically on the serialization and traceability. At Pyrotec, we're proud to have been in business for the last 59 years. We have, just give me a second, sorry, my slides are not, sorry. We have multiple centers across South Africa and partners or representation throughout the African continent. Our company operates through several specialized divisions. PackMark, which focuses on coding and labeling technology. PackMedia, on-pack promotional labeling, including pharmaceutical fix and forms labels. PackLink, which handles our smart factory software solutions. PackPrint is our high-quality litho-printing division. PackWorks, our custom machine fabrication unit. And lastly, PackFinance, which is our in-house financing division, making implementation more accessible to our clients. At Pyrotec, our track and trace initiatives cater for serialization, anti-counterfeiting, and general product traceability, conforming to GMP. We have custom systems designed for multiple custom markets and regulatory requirements. Our focus today is more aligned around serialization within the pharmaceutical space. My colleagues GS1 and NBI have been through the code construction, legislation requirements governing the codes, etc. I'll focus more around the process, around serialization and the product and how to identify and how identification and verification occurs. So at PackLink, we offer robust track and trace solutions with integrated software and hardware systems across multiple environments, and you can see full traceability. That shows you real-time visibility, and that's what every customer is looking for today. NBI approached us with a simple but critical request to design and fabricate a serialization and verification on-pack printing and labeling system that not only meets all legislative requirements, but also integrates seamlessly with the ERP system, which is SAP. So the following slides will walk through the functionality of the track and trace solution and illustrate the data flow of the system. So I want to touch a bit on serialization. Meryl went through this, but I'll focus on the hardware and the data around these units. So serialization, applying a unique identifier on the retail unit of sale, conforming to your GS1 standards. Authentication, confirming the authenticity of the product or the unique identification code. We will go through that in later slides. And track and trace is determining the location of the product as it moves through our supply chain. So aggregation and inference, each item and case in the pallet assigned a serial number. The items are aggregated to your case level, which is your parent-child relationship. And then the cases are further aggregated to your pallet level, which is your parent-grandparent unit. Again, broken down or more simplified, serialization on a consumer unit. So you've got your data matrix code, consumer unit number, aggregation or child-parent association is on a bundle unit, and we can further aggregate it to a case level, grandparent, and then on your pallet level, great-grandparent association. Now, if you go back to your database, you can see the traceability report, and Meryl has been to that traceability report at the end of her slide. You can see the pallet number, and within the pallet number, we've got the individual cases, and within individual cases, you've got your bundle units, and further down the line, you'll have all your consumer units. So GS1 has touched a lot on serialization around the coding and serialization that's occurring globally. Now, you have different types of serialization within the pharmaceutical industry, which we're particularly dealing with today. Serialization within the local environment serialize the product that conforms to local track and trace within the manufactured unit, and sometimes move out to DC or consumer units. In the case of global regulations where your product is exported across multiple countries, then one would have to conform to the different global standards in terms of serialization and aggregation, which now has government bodies involved that actually supply the serialized numbers based on the countries that you're exporting to have a global database of all the numbers that are produced and tracked throughout the world. So as you can see from the different bodies, the EU body, the Chinese body, as well as I think this is the USA body. And later on, I'll leave my details in the chat, and if you require more information, you can communicate with me or drop me an email and I can go through this in more detail. So with the NBI, what we've done in terms of the data tracking, our Packlink software connects with SAP or the ERP system to retrieve the correct master data and product data information. So SAP via an API or web service pushes the XML file to our Packlink database. And within our database, we would then update it and ensure consistency and traceability. The database sequence is used to generate the unique serialized number, and this is also done according to the set of rules or the customer set of rules. So again, NBI has their own set of rules in terms of the way the serialized number is constructed, and we conform to that. So aggregation rules applied in terms of the case, etc., as per predefined hierarchies, which is item, box, pallet. And lastly, Packlink generates a label format using the serialization and the aggregation rules. So as Meryl showed you in the videos, the SKU is selected via the HMI. Now here, the operator or pharmacist select the SKU variant, and this occurs after all the login user verification steps have been followed. And again, once the SKU is selected, Packlink requests the database or the data from SAP, which pushes the data through the database, so the data is processed. The label is created, again conforming to this customer set of rules. So the serialized codes are created and follow the GS1 principles. The information is being dumped to the printers. It's being sent to the camera system, which does the verification. And I'll go through this in more detail in later slides. Again, the case or shipper scanner will scan the information, push it back to the database, where the database then the software will then create the aggregated code for the outer case label. And once the case label is affixed, it goes into stores or warehousing, etc. And here, cases or pallets can be broken down and re-aggregated as per, again, the general set of rules. So going back to the hardware solutions, we have the printer or camera system which interfaces with our database. We dump the information down to the printer to print the relevant information. The same information is sent to the camera, which has the different capabilities, OCR, OCV, which will scan and verify the label on the product. The verification process occurs within the camera to ensure that the correct text data is readable and accurate. Unit level verification, the system proceeds to aggregate, grouping the different units, cases, etc. And each level of aggregation is verified and encoded as per the hierarchical serialization logic. So once all of this is completed, the labeling and aggregation follows the processes. Packlink will then push the data back via an XML file with all the serialized aggregated data to SAP, and this will eventually close the loop to ensure that all records reflect actual packaging operations. So again, SAP sits on the local server or the cloud or any of your ERP systems. The data is pushed by the web service to our Packlink application. Once the SKU is selected, automatically we will dump or send the information down to a printer, camera system, handheld or automated scanning devices, and this could be a normal case or shipper printer or an automated printing system along the line. So how does the verification or camera verification occurs? So camera systems are equipped with embedded AI or software tools that perform automated inspections, which will read, interpret, and validate your printed text, your barcode information on products. And this is essential for data accuracy and compliance within your different packaging or production lines. Now, on the left-hand side, you could see a screen. You've got a camera system that's reading the information of a pack, which has got your barcode or QR code or a data metrics code, and it's got your human readable text. So you can see all of the human readable text is highlighted, and you've seen that in Meryl's videos showing the serialization process. So within the camera system itself, we have two essential tools that are used to read and verify the human readable text. The first tool is what we call OCR, and the second tool within the camera is called OCV. Now, what is OCR? OCR is optical character recognition function within a camera. And this converts your printed or etched text on a product, example, your expiry date or batch numbers, into a machine readable or digital data. So this is your normal text that one would see. The camera takes a picture of this, and this is where the processing occurs within the camera to identify your characters. So it recognizes each character shape and translates the visual representation into your alphanumeric text. So here you can see the same information within the camera using an OCR tool. Within the unit, it identifies the characters as 1, 2, 3, A, B, and C. The second tool within the camera is called optical character verification, or OCV. Now, the OCV tool validates the correctness and quality of the printed data against the expected content or the expected string. So in the previous slides, I've went through the information where our Packlink software creates a label data and sends the label data down to the camera itself. Now, in the camera, the OCV function uses that data and validates the quality of your print. So the quality encompasses a whole lot of different processes where it checks the content, the structure, the visual information. It can also look for smudges, missing strokes, deviations. There's a lot of parameters that one would set within the camera to identify and look for the correct information based on the set of rules. So the same information that we've read on the previous slide, where the OCR portion of the camera or the tool identified the information, the alphanumeric text. Now the OCV performs its function where it'll identify the individual alphanumeric characters against its predefined parameters. So we could look for quality. We could set it from anything from 50% to 80%, and depends on what you want to see on that. Now, if you look at this image, you can see that the ANC has failed on this system because it didn't conform to the requirements or the preset values. In layman's terms, a product like this would be passed by the naked eye. So an example, especially in the pharmaceutical space, why we utilize OCR or OCV technology If you look at a box of medication where we've got a date 7th month 2023. Now, to a person with good eyesight, it'll look at 7th month 2023. But a person with, or an aged person with diminished eyesight might look at that, and the date could resemble 7th month 2026 or 7th month 2028, thereby taking expired medication which cause harm to them. So therefore, the tools within the OCV looks at that and ensures that it meets the standard that's set out. Like you can see here on the left, on the right-hand side slide, ABC 1, 2, 3 could be a pass, but it's failed because of the predefined rules. Again, all of this here because it doesn't conform to the requirements in terms of the formation structure, etc. So the verification process, in summary, the camera captures the image of the printed area on the product. It's got the two set of tools, which is OCR tool extract the data and digitizes it. And the OCV tool compares the extracted string to the predefined parameters that's set within the unit itself. So the date format, allowed values, etc. If the content matches the expectation, the item will pass. If there's any discrepancies or quality issues found, then the items are flagged for rejection. Early on, GS1 spoke about anti-counterfeiting. And anti-counterfeiting is a huge problem across most industries, and in particular the pharmaceutical industry. The funds or the money that can be made from anti-counterfeiting far exceeds funds that are made in illicit trade. And therefore, a lot of people are counterfeiting products. And the one sad part is your life-saving cancer medication, which was most prevalent recently in the black market where it's being counterfeiting. And I think it's more the chemo medication where you're buying placebos on the black market, and that's quite sad. There's a lot of anti-counterfeiting initiatives that are around serialization, aggregation. We have different tools that are used for anti-counterfeiting around serialization, where we've got specialized camera systems that will serialize a normal EAN barcode that looks for deformities. Yes?
Sorry for interrupting. Yeah, we have 1 minute.
Oh, sorry about that.
Yeah.
Okay, I'm almost done. So again, lastly, RFID with serialized product tracking traceabilities. This is one of the stages that we have in terms of authentication. We can utilize RFID. RFID chip is embedded onto a label, and as it passes through the printer, the UID number on the chip is encoded and captured and linked to the corresponding serialized number on the central database. Again, if anyone is looking for more information, I'll put my details in the chat and we can chat further about this.